Hi there, welcome to Lesson 9, Blue Planet. We've probed the inner workings of the atom, we've looked at the cosmic origins of our Earth, and we've measured its age. So this is a great deal of background information that we've gone over. And now we can move on to the more tangible aspects of looking at our Earth, looking at rocks, looking at why things are the way they are. So to do that, we'll look at why a lot of phenomena exist and how they got that way and what our Earth's made of. So to start, we need to answer the question of how things got to be the way they are. Why are there oceans in some places, mountains in others? There are all sorts of strange phenomena that occur on Earth that are somewhat difficult to explain and haven't even been explained until, say, the 1950s, or quite recently anyway. Some of which are all these deformed rocks we find on Earth's surface. We find rocks that are folded and pushed across each other and smashed and pulled apart. They've undergone a lot of stress. We find ocean fossils on mountaintops where it seems unlikely that there could have ever been an ocean. We find that the jigsaw fit, so-called, of the continents is compelling evidence for something, but we don't know what. We find glacial rocks near the equator, and we find fossils that could never swim across oceans on different continents. So there are all these strange mysteries that took a very long time to figure out, and we'll go over why and how that came about and how we've solved it since. The other question I'd like to answer is what the Earth's made of. It's sort of hard to imagine because we live our lives on a very thin little skim right at the surface of the Earth. We can't go very high above the surface of the Earth and we don't get very low below it. So we live on this very thin crust of the Earth. And what's underneath is sort of a mystery to most people. So those are some of the questions of how things got to be the way they are. But what's the Earth made of? We've known for 2,200 years how big the Earth is. Eratosthenes figured that out in a beautiful way 2,200 years ago, 200 BC-ish. And so we've known that for a long time. We've measured how big it is. And from that we know that there's a lot of stuff inside the Earth. And it's actually quite interesting the way that we figured out what that stuff is and just how it's composed. These are pretty big topics, and usually it would take, 4 years of university to really get a good handle on these. But we'll try and cover them in the best way that we can, and I think we'll do a good job. First thing we'll have to do is forget what we know about maps and sort of visual representations of the globe, because we're so used to looking at political boundaries, where Spain is, where Russia is, where Canada and the United States are split, that I think we sometimes forget that the Earth is split up by geographical boundaries as much as anything. Let's look at the Pacific Ocean to sort of illustrate this. Now, the Pacific is a massive ocean. It is huge. And it just goes to show that by looking at this view of the Earth, we sometimes don't even know our own Earth that well. The Earth's 2/3 covered in water, and astronauts who've been at the space station say that, in fact, they don't often see that much land. They mostly see oceans as they look at the Earth from space. Now, the oceans are pretty mysterious. They're difficult to research, and it's only in the past 50 or 60 years that we've made any headway at all in studying the ocean deeps. Before that, it was really just the realm of monsters and mysteries and myth. Although we didn't know much of anything useful about the ocean floor until the 50s or 60s, that doesn't imply that geologists weren't working hard elsewhere in the world. Some of the biggest findings and most important lasting legacies come from studies in the Alps, the Swiss Alps, where geologists would climb these almost untraversable mountains, carefully mapping and modeling them. And some of their work was really fascinating and instructive, so we'll go over that in the next lecture.